Hello guys, welcome back to my YouTube channel. I'm Ananya, currently pursuing my bachelor's degree in Sri Venkateswara College of Engineering in the Department of Computer Science and Cyber Security. Today I'm here with the topic called Kruskal's algorithm. So let's dive into the topic soon. Algorithms overview. Kruskal's algorithm builds a minimum spanning tree by first sorting all edges of the graph in non-decreasing order of their weights. It then adds edges to the minimum spanning tree one by one, ensuring no cycles are formed, which it checks using the disjoint set data structure. This structure helps efficiently manage and merge sets of vertices, allowing the algorithm to quickly determine whether adding a new edge would create a cycle. By repeating this process until the minimum spanning tree is complete, Kruskal's algorithm guarantees the resulting tree is of minimum total weight. Next is the steps involved for Kruskal's algorithm. Kruskal's algorithm begins by sorting all the edges of the graph in ascending order based on their weights. Next, it iterates through the sorted edges and adds each edge to the minimum spanning tree if it does not form the cycle with the edges already included in the minimum spanning tree. This process is repeated carefully, selecting the edges that maintain the acyclic property until the minimum spanning tree contains exactly v minus 1 edges, where v is the total number of vertices in the graph. By adding the smallest available edge that avoids cycles, the algorithm ensures the construction of the minimum spanning tree. Next is time complexity and efficiency. The time complexity of Kruskal's algorithm is theta of E log E, where E represents the number of edges. This complexity is primarily driven by the initial sorting step, which makes the algorithm particularly efficient for sparse graphs. The use of union find data structure significantly enhances the performance by optimizing the process of cycle detection, ensuring that the algorithm operates efficiently while constructing the minimum spanning tree. Next, let us consider the example to understand how the Kruskal's problem is solved. Let us consider this as an example. First, we have to consider the least values and include them. The least values should not form the cycle finally. In this given example, the least value is 1. Next, that is 2. Next is 3 and so on. First, we'll consider the least value 1. Where all do we have 1? From D to B it is 1 and from F to G it is 1. We'll consider these two and draw it in the minimum spanning tree. From D to B 1 and from F to G it is 1. The next minimum value is 2. Where all do we have 2? D to E is 2 and A to B is 2. We'll consider these two values also because it is not forming the cycle, and we'll draw it in the minimum spanning tree. A to B and D to E. The next least value is 3. But if we consider the value 3, it forms a cycle. Here Here the value of 3 is given, but if we consider the value 3, it will form a cycle. So we are not considering the value 3. We'll jump to the next value, that is 4. Where all do we have the value 4? Here we have 4 and one more is here. If we consider this 4, it forms a cycle again. So we won't consider the value from A to D. We'll just consider the value from B to G, that is 4, and draw it in the minimum spanning tree. The next least value is 5. If we consider this 5, it forms a cycle. So we are not considering the 5. We'll jump to the next value, that is 6. Where all do we have 6? We have 6 from G to C. It is 6. We'll consider that value, that is 6. After this, finally, we have to add all the weights so that we'll get the total weight of the minimum spanning tree. Here, 2 plus 2 plus 1 is 5, plus 6 is 11, plus 4, 15, plus 1 is 16. So the total weight of the minimum spanning tree is 16 here. Thank you.